Good morning, students. Now we discuss about the energy stored in an inductor. In the last class we discussed about the self-inductance, right? Okay. Next here we already discussed the energy stored in a capacitor. Similar way we have to find the energy stored in an inductor. So to find the inductor we have need a power supply, right? So power supply means what we have to do? We have to take the power. So what is the formula for the power? We know that the power is nothing but the rate of change of doing work. So power is equals to the rate of change of doing work. So we have the formula of power P is equals to V into I. Right. So let me take here the work done. The work done. dW be the work done by the inductor. Work done by the inductor. With respect to inductor, with respect to time dt. With respect to time dt. Work done with respect to time dt is nothing but the rate of doing work. Rate is nothing but the time. Okay. Then next we have to take here the work done with the formula we have to take, that equals to dW by dt is equals to, we taken as an a power. dW by dt is taken as a power, or power is equals to, we can written as an P is equals to dW by dt. So we know that P is equals to what we are written? V. So here V is nothing but the voltage, but we have considered in the classes we are taken as an V is equals to E. So for that we have to substitute dW by dt is equals to P is equals to, instead of P what we have to write here? VI. So instead of V what we have to write here? dW by dt is equals to what we can written as E into I. Okay. So next we have to substitute for the I. E is nothing but the, according to the Faraday's law, what will be the E? By the self-inductance, E is proportional to the pi is proportional to the current. So for that what we can written as E is equals to L into di by dt. Right. E is equals to L into di by dt. So let me take here. So dW by dt is equals to what we can written as an E is equal to L into di by dt into I. Okay, this is an L into di by dt into I. Next we have to integrating on both sides, So when we get the integrating, we have to take the limit from I is equal to 0 to I is equals to I. I is equals to 0 to I is equals to I. Let we have to take. Then you can see here dt, it will be cancels. Then the remaining is dW is equals to L into di into I. Okay. Then integral dW is equals to integral of L into di into I with the limit 0 to, this is W means we have to, then with the limit of you have to take here I 0 to I. Okay. Then next we have to integration of dW is, it is in the form of integration of dx. Integration of dx what we get? We get that x. Integration of x what we get? X square by 2. ಅಂದರೆ ಇದು ಯಾವ ಫಾರ್ಮಲ್ ಹಾಕಿದ್ದೀನಿ ಅಂತಂದರೆ x to the power of n ಅಂದರೆ x to the power of n plus 1 by n plus 1 ಫಾರ್ಮೆಟು, ಆ ಫಾರ್ಮೆಟಲ್ಲಿ ಹಾಕಿರೋದು. ಈಗ x ಪವರ್ ಏನಿಲ್ಲ ಅಂದರೆ ಏನಂತ ಅಂದ್ಕೊಂತೀವಿ? 1. ಸೊ x ಪವರ್ 1 is equals to x power 1 plus 1 by 1 plus 1. That will get x square by 2. ಈ ಫಾರ್ಮೆಟು. ಸೊ ಹಾಗಾದರೆ dx is equals to x ಅಂತ ನಾವು ತೊಗೊತೀವಿ. ಹಾಗಾದರೆ dw is equals to what we can written as an, we can taken as an a w. So limit ಇದೆ, we have to apply 0 to w equals. Then next ಇಲ್ಲಿ L ಇದೆ ನೋಡಿ, L ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಆಗಲ್ಲ, ಯಾಕೆಂದರೆ I ಮತ್ತು di ಎರಡು ಇರೋದ್ರಿಂದ I ಮತ್ತು di ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಆಗೋದ್ರಿಂದ L ರಿಮೂವ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಆಚೆ ತಗೊಳ್ಳಿ. Then we have to write integral of 0 to I, ಇಂಟಿಗ್ರಲ್ ಹಾಕಿರೋದು ನಾನು ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡ್ತಿಲ್ಲ, I into di. ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ತಗೊಳ್ಳಿ, W ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಮೈನಸ್ ಲೋಯರ್ ಲಿಮಿಟ್ is equals to L into, ಇದೇನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ದೀನಿ ಈಗ I ಅಂತ ಅಂದರೆ ಇಟ್ ಈಸ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ x ಪವರ್ 1 ದಟ್ ಈಕ್ವಲ್ಸ್ ಟು I ಪವರ್ 1. ವಾಟ್ ವಿ ಗೆಸ್ಟ್? I ಸ್ಕ್ವಯರ್ ಬೈ 2. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಇಲ್ಲಿ I ಸ್ಕ್ವಯರ್ ಬೈ 2 with the limit of 0 to I. So the next W minus 0 is W is equals to L into, ಇವಾಗ ಇಂಟಿಗ್ರಲ್ ಹಾಕಿ ಇದನ್ನು ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡಿ, I into I square by 2 minus 0 square by 2, I ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ. ದೆನ್ W is equals to L into, ಈ ಟರ್ಮ್ ಓಲ್ಡ್ ಟರ್ಮ್ 0 ಆಗುತ್ತಿದ್ದು, ಇದು ಓಲ್ಡ್ ಟರ್ಮ್ 0 ಆದರೆ I square by 2 ಬರುತ್ತೆ. So the energy stored, that is work done, energy stored in a what we call as an inductor is Li square by 2. So this is an expression of the energy stored in an inductor. It is depends on the self inductance and the current flowing in the circuit. So this is very important for the 3 marks question. Okay, then next we have to discuss about the mutual inductance. So mutual inductance means we have discussed the self inductance, the coil, the current generated in the one coil and also the EMF induced in the same coil. But in the case of the what we call as a mutual inductance, in the mutual inductance we can take an as an 2 coils we have to take. You know that in the transformer, let me consider the transformer. In that it consists of a number of turns. This we can take as a primary coil and this we taken as a secondary coil. Here when current is passed, when we current given to the primary coil, the voltage can be seen in the secondary coil is nothing but the current will be induced in the produced in the primary coil and the EMF voltage is nothing but the EMF is induced in the secondary coil. Similarly, if the current is given into the secondary coil and the voltage is induced in the primary coil. So from this what we can take an as it will be mutually transfer from the primary coil to secondary coil. ಇಲ್ಲಿ ಕರೆಂಟ್ ಕೊಟ್ಟಿದ್ದೀವಿ ಅಂದರೆ ಇಲ್ಲಿ ನಾವು ಸೆಕೆಂಡರಿ ಕಾಯಿಲ್ ವೋಲ್ಟೇಜ್ ನೋಡ್ತೀವಿ. ಇಲ್ಲಿ ನಾವು ಕರೆಂಟ್ ಕೊಟ್ಟರೆ ಮತ್ತೆ ಸೆಕೆಂಡರಿ ಕಾಯಿಲಲ್ಲಿ ವೋಲ್ಟೇಜ್ನ ನಾವು ಯಾವ್ದು ನೋಡ್ಬೋದು, ಪ್ರೈಮರಿ ಕಾಯಿಲ್ ನೋಡ್ಬೋದು. ಸೊ ಫ್ರಮ್ ದಿಸ್ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಕನ್ಕ್ಲೂಡ್, ಇಲ್ಲಿ ಏನಂತ ಹೇಳ್ಬೋದು, ಒನ್ ಕಾಯಿಲಿಂದ ಇನ್ನೊಂದು ಕಾಯಿಲ್ಗೆ ಎನರ್ಜಿನ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತಾ ಇದೆ. ಸೊ ಅದನ್ನು ನಾವೇನು ಹೇಳ್ತೀವಿ, ಮ್ಯೂಚುವಲ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಾ ಇರೋದ್ರಿಂದ ಮ್ಯೂಚುವಲ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಇದನ್ನು ಕೂಡ ಇಟ್ ವಿಲ್ ಬಿ ಡಿಪೆಂಡ್ಸ್ ಆನ್ the magnetic flux is directly proportional to the electric current. ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಇಸ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದಿ ವೈರ್. ನಾವೇನು ಕಾಪರ್ ವೈರ್ಸ್ನ ಸೊಲನಾಯ್ಡ್ ತೊಗೊಂಡಿರ್ತೀವಲ್ವ, ಇಟ್ ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್ ನಾವು ಟ್ಯೂನ್ ಮಾಡಿರ್ತೀವಲ್ಲ, ಅದನ್ನ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. when the magnetic field is linked with the current, then it is induced the what we call it is induced in the EMF. So from that what we can take as the magnetic flux is directly proportional to the current flowing in the transformer or a circuit. Then the proportionality constant we can take as the pi is equals to m into I. This is the proportionality constant we have taken as a constant, m into I. M is nothing but the mutual inductance. So what is an SI unit then? The SI unit of the mutual inductance is also called as Henry. So it is derived from the Henry, scientist Henry. It is also induced by the ಯಾರ ಹತ್ರ ಡಿಸ್ಕವರ್ ಆಗಿರೋದು, ಹೆನ್ರಿ ಇಂದಾನೆ. ಯಾವ್ದನ್ನ, ಮ್ಯೂಚುವಲ್ ಇಂಡಕ್ಟೆನ್ಸ್. ಸೆಲ್ಫ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಮತ್ತು ಮ್ಯೂಚುವಲ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಇಬ್ಬರು ಒಂದೇ ಮಾಡಿರೋದು, ಗೊತ್ತಾಗುತ್ತಾ? ಓಕೆ. ಸೊ ಹಾಗಾದರೆ ಮ್ಯೂಚುವಲ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಏನಂತ ಹೇಳ್ಬೋದು ಅಂದರೆ, the current flowing in a one coil, the EMF induced in the another coil, that is called as a primary coil and the secondary coil. Okay, in the next class we discuss about the expressions of the mutual inductance. Thank you.